Okay guys, hello and welcome back to the third part of this video tutorial on brain MRI segmentation. And in this video we are going to pre-process our data and generate some of our code for the pre-processing. So let's dive into that. So first we are going to create pandas data frame. So that is df equal to pd dot data frame, and data we are going to pass as the image file name, and then that is going to be the image file name train. We are also going to add the mask, that is mask as a parameter, and that is going to be mask files obviously. Okay, okay guys, so here we are, and now let's do some train test splits. That is we are going to do over here. And we are going to use a function called train test split that is in the scikit-learn library that we have imported earlier, and we are going to pass data as the df that we have generated in the upper line. And for the test size we are opting for 0.05, that is 5% of the total data, that is 3929 into 0.05. You can calculate by yourself, and we'll see in just a minute that what is going to be that. And before we do that, we are also going to create the validation data for our loss matrix and some other parameters. So in that too we are going to use train test split, but in this one we are going to pass the df underscore train that we have just computed in the earlier step, and we are going to pass the train size, or the test size as 0.05 again. You may choose as per your convenience, there's no hurry in that. So now let's check the size or shape of them. Df underscore train dot shape. So guys, as we can see over here, dot shape is a method that shows us the shape of our data frame, and tab 9 is working pretty accurately. As you can see over here that df underscore train, that is our training set, has 3545 out of 3929 total images, and its shape is 2, that is it's a 2D. Also 187, that is the shape of validation data, and 197, that is the shape of testing data. Alright, so now a major part, that is creating a generator, that is a key part in this pre-processing phase. Train underscore generator, and then in the parameters we are going to pass data frame, also the batch size. Don't worry guys, each and every parameter I'm going to explain in the next video or in the next few minutes if possible. Augmentation dictionary, that is augmentation underscore dict. The augmentation dict will contain all the parameters like rescaling the images, transforming or rotating the image, and fading and all that, and we are going to say in that moment. Then we are going to pass the color mode, that is RGB, that we are using currently. RGB, sorry. And mask color that we are going to use for our output image that is going to be grayscale, so that we can generate a quite accurate output. So now, okay, let's print it in the next line so that we can see over here. Okay, so image that we are going to, that is we are using image prefix, that will be image itself, that is image save underscore prefix. Point to be noted is that we are going to pass the parameters predefinedly over here that we are defining, and that are going to be almost same for each and every iteration. Only the difference will be the augmentation and the data frame as well as some batch size. Okay, so here it will be image save prefix. Okay, I mask save prefix, and that is going to be mask obviously. And now if anyone want to save their models, they can do over here, save to directory. I'm currently not interested in doing that, so if anyone wants, they can do that. Target size, this is an important parameter. So target size of our image would be 256 cross 256, because as we know that we have defined our height and width to be 256 cross 256. That means that the image that we are generating over here, that will be of 256 cross 256. And last important parameter, that is seed, that is we are going to set as 1. Alright, why it is showing, and okay, yeah, it's a function, so we are going to define now. So what we are going to do is, we have imported a method called image data generator, and we are going to pass the augmentation dict. Okay, augmentation dict, and for the same we are going to do is mask underscore data gen, and again tab 9 working quite well. And also let's create image generator. Okay, so what we are going to do over here is image underscore from flow from data frame, as you can see over here, and then data frame, that is equal to data frame directory. I don't think we are going to need directory. Yes, x underscore column, we are going to need that. Okay, let's type by ourselves, equal to image underscore data gen dot flow from data frame, and then for the data frame we are going to pass data frame itself, comma, the x column would be our image file name train, the class mode would be none. Sorry. Okay, and color mode would be image color mode, that is the color mode of the image itself, that is the grayscale in our case. And then target size would be target size, because we have defined it earlier. So target size equal to target size itself, and then batch size would be batch size from the parameters. Okay, let's type in the next part. Okay, and then save to directory is going to be equal to our parameter that we have got from the parameters arguments itself. and save prefix also we have to do that. That is going to be image save prefix, save underscore prefix, image save prefix. Okay. And last parameter, yeah, seed is remaining, so let's do seed equal to seed. And yes, the image generator is created, and I think so. Let's just get from over here. Okay, yeah, it's quite visible now. Okay, so now what we are going to do is we are going to generate the same for mask generator from data frame, and let's just copy this one, and let's see if there are some error. Oh, okay, some changes or what. And the x colon would be, I think so, x column would be image, no, that would be mask. Yes. Okay, and class mode would be none. Yes, that's perfect. Color mode would be color mode. Target size, batch size, save directory, yes, all are same. Over here, yeah, there's a change. This is mask, save prefix. Okay, yep, yeah, I think so. That's all we need for right now. And then train gen, yeah, we are going to zip it. That is zip, and then we are going to zip image generator, comma mask generator. Okay, so what we did over here is we just combined these things, and to form the mask as well as the image generator for the pair of images as well as the mask. So what we are going to do is for image mask in train underscore gen that we have just created, we are going to simply normalize them. And don't worry guys, we are going to create it generalize image comma mask. Okay, and we are going to yield, obviously that is going to be the return one. Okay, so now let's just define this normalize and generalize. Define normalize underscore and underscore generalize generalize, yes, comma img comma data, obviously. So what we are going to do over here is we are going to generalize our image and our sum of our images, and we are going to do by dividing first the image by 255, as we know that that is the RGB point. Okay, so and then we are okay, sorry, equal to. Okay, so now what the same for the mask one, and then we are going to create the mask, that is probability for the mask, that is mask if 0.5. If mask is greater than 0.5, then that will be 1, or else mask is less than 0.5, less than or equal to 0.5, then it is going to be 0, obviously. Then we are going to return image comma mask, and that's it guys. So we have just normalized and generalized. Okay, let's do one thing, that not write down as generalized but diagnose, so it would be easy for us to do some other course. Sorry. So diagnose. Okay, so In this video what we have done is create some data generator as well as normalize and diagnose, and going to write dice functions. So dice coefficients are nothing but the sum of our losses and the parameters, sorry, optimizers and the parameter losses as well as the optimizers. Alright, so what we are going to do is I'm going to fast forward now, because you can refer to the coefficients in the links given in the description below. So that will be y underscore true, y underscore pred, comma sm double smooth, that is going to be 100. These are just some parameters that we are using right now. Y underscore true underscore flatten, that is going to be k. K is nothing but the sum of our library imports that we have already done, and then y underscore pred okay, tab 9 is good again. So intersection, that is k dot sum obviously, then union is going to be, wow, it is showing quite accurately, nope, not showing, dot sum, obviously dot sum, and then the thing is we are going to sum y underscore true underscore flatten with, okay, now it is showing quite accurately, and then we are going to just return. Okay, that's quite good. So the thing over here is that dice coefficient that we have just defined, what it does is basically that it flattens out our image into a single parameter, that is single tensor, and then it checks that what is the percentage of the intersection that is happening over here. So let me show you how it's done using an image. Okay, so what it does is that the intersection of this both, that is, just consider this as a Venn diagram, and the intersection part that we are using over here, that is the overlapping part of the both images, that is accurate, that is like the true image and the predicted image, and if that we are going to multiply by 2, and then we are going to divide it with the sum of that two images. So over here what we did is we just flattened them out, the images, and then we intersection, that is a numerator part we have over here, and then we are returning over here. But what we are returning over here is quite important. We are returning 2 times the intersection plus smooth. Smooth is nothing but a parameter that we are using just for our convenience, and then we are going to divide it with the union plus smooth. Again, smooth is just a convenience term, you can change it according to your things. So what the next thing I'm planning to is loss, obviously dice coefficient loss, dice underscore coefficients loss, and then y underscore true smooth, obviously it's correct, and then we are going to just simply return the negative of dice coefficients smooth. Okay, so this was our loss, obviously loss will be in the negative part, so we are just returning the negative of it. And now what we are going to do is define the IOU, that is intersection over union. IOU is nothing but the thing that we did in above, but next term ahead, that is okay, that is true, and colon, and then intersection would be y true times y pred, correct, and then sum would be k dot sum over y not intersection, y underscore true, not flatten, y underscore true plus y underscore pred, and obviously IOU would be intersection plus smooth, plus smooth, and that would be divided by sum, that is sum minus intersection plus smooth, and we are just simply going to return it. And one major thing is I just left off, that is Jacquard distance. don't worry guys, this whole code would be on GitHub, so you can just, if you don't want to just hustle off, then you can just copy it. And if you want, I can create a video on how to just download it from GitHub and run it on your local machine. So if you want that, just comment it in the below comment section. Flatten and then y_true, and each and every link that I am referring to now, like IOU or dice coefficient loss or anything, that would be in the description below. Don't forget to check that out. Okay, so I think yep, so we are going to just return minus of IOU and then y_true_flatten, comma, y_bread_flatten, and yep, this is going to be our dice coefficient and all the losses and other things. So in this video what we learned is that how to generate and augment our data and how to create a function that would do that. Okay, and in this section we have learned about dice coefficients, IOU, as well as the checkout distance. So let's see now what is the next part. So next part would be, I think so, yes, unit architecture. And in next video I'm going to explain you about the unit architecture, as well as we are going to code it. And if you want, you can code along with me, or you can just copy it. No worry guys, I have done that too sometimes, not always. Okay, so see you guys in the next video. Till then, stay tuned.